Okay, we are finishing the graphing notes. Guys, this is our last lesson of the semester.
Yeah, let's go.
From here on out, just review and assessments, baby. Okay, we left off with level 8. And this is good review from what we did yesterday. So we're going to do one graphing, couple writing equation ones, one graphing calculator. Let's get after it. Okay. So when I see this one, now notice that the vertical shift here is written in front of the trig function. That's okay. That's the same thing as over here, right? What does that mean with my curve? What's that going to do?
Midline is at -1.
Good, yeah. It shifts down 1, and my midline is now going to be at y equals -1, where it normally sits on the x-axis. Okay, before I draw in my midline, I do want to check out my amplitude. What's my amplitude here?
2.
2. Good. So I want to make sure that however I scale my axes, like so, if I decide to call this -1, that I can still go 2 below and 2 above. That's how I scaled it. Again, we try to use as much graph as we can. You don't have to do that, but if you don't kind of space it out, it's just going to be a really tiny graph, which is fine, but you get to manipulate the axes, so use up as much graph as you can. Okay, so our graph shouldn't go lower than -3 or higher than 1 because that's exactly like a distance of 2 away from your midline. That's what amplitude is. All right, then we find our period. So we take whatever horizontal transformations are going on. We set up this inequality. And we solve for x. So first I would subtract pi. So that just got shifted over. Then I would times everything by 2. That stretched everything out. Period is this length is 4 pi. Yep. Period is now 4 pi. Okay, so this one I have to start at -2 pi and end at 2 pi. So we're going to have to backtrack a little bit here. You could change where your y-axis if you want, but all I did was I said like this is pi, and then I just added in one more box to make -2 pi. But you could change your y-axis. And again, on like real graph paper, you'll have more to work with here. I just screenshotted a little bit. So we're counting up every 2 boxes is pi, or we're counting up by pi's over 2. So this would be pi. This would be 2 pi. And that's pretty good space for 1 period. Again, ideally, probably could have spaced it out a little bit better if we had more room. But let's keep going. So then this would be 3 pi. This would be 4 pi. 5 pi. 6 pi. That's 2 plus another 4. Okay, so that's good. Now I kind of have everything nicely labeled. I know where to start and where to end. Then I got to check out, is it a cosine or a sine, and do I have any reflections? No reflections here. Don't let that negative throw you off. That's a shift. The amplitude is still like that +2. And it's a cosine, and cosine starts at what type of point?
At the max or min?
A max. Yep, a max. So at -2, where I'm starting, I'm going to have a max here at 1. And then I'm going to end where I started. So at 2 pi, I'm going to go back at a max. What happens between the 2 maxes? Exactly halfway between them.
Crosses.
Nope.
It's the min.
A min. What happens between the maxes and a min?
It crosses the x-axis, or the midline.
Crosses the midline. Good. So it should cross at -pi and at pi. You can draw that in. Remember, keep it curvy. There's 1 period for cosine. And And then we're just going to continue in this pattern. So we know our period length is 4 pi. So if I start a new cycle at 2 pi, it's going to end at 6 pi, halfway, min, halfway, crosses the midline.
It's magical.
And folks, that's about as hard as they get when you have like a midline shift and a phase shift. So if that felt okay, you should be good. If it didn't, don't worry. You get to practice some in your homework.
I don't know.
No, you do. You do get to practice.
This is wrong. Way wrong.
Oh, I don't have a Chromebook or book.
Domain is all reals. My range is what, folks?
I know what I did wrong.
Negative 3 to 1. Okay. Questions?
Can we stop for the day? No. For the shot.
We did, but like.
You could have also, guys, you could have like started at 2 pi and did like 2 cycles like that way if you wanted to. You don't like have to do, you know what I mean? Because it's cyclic, like it's going to repeat. It's periodic, it's going to repeat. So all you have to do is 2 cycles. I just like to do this because this works every time. Tell them where to start, where to end. But, you know, ideally you could do that, right? Start it here, do another full 1 to 10 pi. Okay. All right, now we're going to be given the graph, and we have to write the equation.
That's no one.
So we're going to do a couple like baby step ones first. Where they tell us, like in this first example, they say like, hey, this is a cosine curve. And all they want us to do is find A, which would be our amplitude. And they want us to find D, which would be where my midline shifted. Okay, so I know you guys can, look at this and figure out where the middle is. But if you're ever not sure, you know, find the difference between your max and your min. And then, just take half of it. So there's like kind of your thinking there. But this one's a pretty easy example. But once we do, we're going to do
how do
one.
you find D?
This, what I just said. So, okay, hold on. Let me just finish what I was saying. No, I forgot what I was going to say. We're going to do one with like real data in a second here. So if it's not something where you can easily just like figure out halfway, you just have to take the highest point, the max. I can write it out. You take the max minus the min and then figure out where half of it is. And that'd be your midline. Okay? All right. So they don't want me to find like the period or anything like that. They're saying just let it be the 2 pi, let it be the normal. And you can see that here. If we like start it here, it ends at 2 pi. They kind of cut it off a little bit. But I do need to find my A, which is my amplitude. So remember, your amplitude is your distance from the midline to the max. So, this is my thinking here. Yeah, in this case, it's 4. Now, careful here, because we have to factor in, look at where this starts. It starts at a min. So how does that affect my actual A value?
Negative.
Should be -4, yep. So with a reflection, you guys kind of see that? A would actually be -4 in this case. Because this is my cosine curve, they told me that. They're saying nothing's happening with our period, it's just saying it's starting at 0 and ending at 2 pi, and it's starting at a min. So technically when I go to write the equation, I'll do that right here. A is -4 cosine of x plus 4. And then you can quick check like if this makes sense. You know, if you were to graph this, you're like, okay, I have an amplitude of 4. Yep, that makes sense. I have a vertical shift up 4. Yep, that makes sense. And this is a cosine that starts at a mid that has a period of 2 pi. Okay. That one wasn't bad because all we had to look at was the amplitude and the midline shift. It gets a little bit harder when we have to figure out the period and the phase shifts, but have no fear. There's a little formula that kind of helps us. All right, so this time they're telling us, hey, you have a sine curve here, and I want you to find A, B, and C. There's no midline shift because look at the middle of my graph, or the difference between my max and min is just 0, right? Halfway between my highest and lowest is 0, okay? So there is no D here. Now notice, if this is a sine curve, sine normally like starts at an intercept, right? So it's not starting right at the origin. So I do have some type of like shifting going on here. Everybody see that? And look at how they're counting up on your x-axis. They're calling this pi, which means this dash mark would be pi over 2, which means it looks like it's starting at about like pi over 4, right? Okay. Now, we know we're going to have some B and C factors, but I would probably start with the easy one here. We can easily tell what the amplitude is. 2. Yep. Amplitude is 2. Okay. Now I got to figure out this period. So you should be able to tell from a graph the length of one cycle. So folks, if this starts over here at negative pi over 4, because I'm thinking sine curve, where does it look like it's finishing?
5 pi over
The
3
length,
pi over 2.
the length of the
7 pi over
the length of the period.
Thank
What
you.
the?
Bro.
Okay,
I need
okay.
to close.
7 pi over 4. So, guys, it's counting up by halves, right? So half,
The length
2
of the
halves,
period is
3
2 pi.
halves. 3 halves is how many fourths?
6.
6 fourths plus another fourth, that's 7 fourths. Just fractions.
But the length of the
How am I
period
supposed
is
to tell
2
that's
pi.
7 fourths?
Okay, yeah, you're right.
Just
Yeah.
know. If you're
That's
smart,
what I was
Bailey,
saying.
you know.
No,
How do you know
Jackson.
exactly halfway?
Jackson, I just explained it. Listen.
Bailey,
See how they're counting up by halves?
Oh, wait. Shouldn't you get
Do you see how they're counting up by halves
um?
on the x-axis?
Shouldn't that be?
Do you see this is marked pi?
Yeah,
Okay, so what would this be?
pi over 2.
Okay? What would this be?
3 pi over 2.
So 3 pi over 2, 3 halves plus another 4.
it's 6 fourths right now.
7 pi over 4.
Yep.
Wait, how am I supposed to know that's a half?
Yeah,
That was another.
it doesn't really mark it, but,
Yeah, how do you know it's not a fourth of a fourth?
well, that
Well,
doesn't make sense.
Because
That
you can't see the next dash mark.
a fourth of a fourth would be like an eighth. That'd be like right here. Yeah, it's not marked. We're just assuming it's half. It is, but this probably can.
Yeah,
Just assuming.
with exception.
Okay,
It's 2022.
so it's starting at negative pi over 4. Now, Ashton, you said this perfectly. So what's the actual period here? What's the length?
2 pi.
2 pi. All right. The period is 2 pi. Now we need to figure out what B is. So I mentioned to you guys, oh shoot, that ink didn't save from last time. This would have been perfect. I was going to page back. I mentioned to you guys one time that you could easily find the period by doing 2 pi divided by whatever B is. So that like factors in the horizontal stretch or shrink. Okay. And we technically do that when we do this. To figure out what the period is, we like divide by this number here. Divided by 1/2 is times it by 2. So in this case, if our period is 2 pi, B would just be 1, right? Because there's no changing on that length. B would just be 1. We're going to do an example where it's not, but algebraically, that's how you could solve it, is knowing, hey, if you know what the period is always 2 pi where it starts, divided by any horizontal stretch or shrink factor, and then you can figure out what B is. But here, since our normal length of a cycle is 2 pi. This one didn't change. So there's no horizontal stretch or shrink factor. Well, I shouldn't say no. There's a factor of 1 there, right? Okay. Now C, that's my horizontal shifts. That's going to affect my phase shift. So I know you guys could figure out that C right here obviously got shifted over to pi over 4. But
The opposite next to X.
yes. Yeah. So C in this case, if I wanted to shift it left, would actually be negative pi over 4, yeah. But I do want you to write this down because some people will forget to do this. If there's a horizontal stretch or shrink factor, you do have to factor that in to C. So here in this case, my shift over was negative pi over 4. Now, since there's no horizontal stretch or shrink, or since B is just 1 here, C is going to be negative pi over 4, which again, I know you could probably like figure that out without doing this formula, but they do get a little bit harder. So let's write our equation. I'll explain this a little bit more, and you can hopefully kind of see it. Amplitude is 2. B is just 1, so it's a sine of x. Minus negative pi over 4 will be plus pi over 4. Okay, so again, connecting with this horizontal transformations, this would just be a shift to the left pi over 4 units, and there's nothing that's stretching or shrinking out my period. A way you can check your answer, and I sometimes do this, is I just take this, set up my period, and see if it matches like the starting and ending point that we picked for this cycle. Because there's actually multiple answers you could do for these, and we could have even called it a cosine curve that starts here and ends here. We could have. Okay, and your textbook will say that, like, this is just a sample answer. I just usually pick, like, the one that's close to the origin, kind of like the easiest one. So if I set this up here,
So
subtract pi over 4 from everything, this should start at negative pi over 4 and finish at 7 pi over 4. And it does. Okay, does that kind of make sense? Okay, we're going to ask a question.
So for the one above, could you technically start at negative pi and then end at pi, and then it'd just be
Yeah.
an auto-reflected?
Yeah, you could have. Exactly. Yeah. Yeah, you could have done that. We would have got positive. Well, no. Actually, no. You can't do that. Because now this factors in a shift. This now factors in a shift to the left, which if you would have, like, added that
You
in,
would have added in the shift.
yeah, you could have, but here they didn't want you to. Right? They didn't say, like, find a B or C. Good question. Does that make sense, though?
Yeah.
Okay. Good. Yes, sir.
Go over how you've got negative pi over 4 again.
Here? Or
Yeah,
here?
Like when you
This
solve
one?
for C.
This is where I, like, started. So we're kind of working backwards. Like, we know this. We got to figure out this. So this is where we started. So you can find C, and I said, like, this is just a little, you don't really need this formula for this one, but you do have to factor in, like, was there a number here that when I solved this, I ended up dividing that number to get to my starting position? So you have to, like, factor that in to finding your C. We're going to do one like that. I think it's next. Yeah, next we go. Where there is a change in our period, I think. Yep. So basically, like, this is what we know, and we're trying to figure out, like, the equation, like, where it came from. And so I said once you get your equation, like, you can quick check it and see if it fits your curve. Okay, we're going to do 2 more. Okay, this time there's no picture. They're just, like, telling you what's going on here. So they say you have a sine curve, and it has a period of pi. It has a period of pi. So that's going to affect my B and my C. Well, it's going to affect my B. We don't know if there's a shift until I read on here. Okay? That's going to affect my B. You can write that up here if you want. That's going to affect my B. They tell me what my amplitude is. That's my A. I do have a phase shift. That's C. And I have a vertical translation. What's that going to affect? D, my midline.
Oh.
Okay. So we're going to start with, like, that this. It says sine curve. A sine of bx minus c. Oops. Plus d. This is just like our basic sine and cosine curve. I put this back in your notes. Sorry, I'll go back a second.
On the test,
Right
will
here.
it give us this.
No, you need to know this. And we talked about like which each variable, how it affected our graph, right? How the amplitude would make a stretch. That was what that A value was. And we talked about like how these affected my period. So this you need to know. This is kind of like it's kind of like this basic form of an exponential, what we did in chapter 3. This is the basic form for exponential. This is the basic form for sine and cosine. Okay, so I'm just going to start with the very first thing that was given to me. We know this has a period of pi. So I know my period normally starts at 2 pi, and whatever b is, I have to like divide it by that horizontal stretch or shrink factor. So if I know my period is pi, you can do a little algebra here. That means b would have to be 2. Because think about it, you're horizontally shrinking this. That makes sense? Okay. Next, they tell me I have an amplitude of 2. So that's pretty straightforward. That just means my A is going to be 2. Here's kind of the tricky part. A lot of people think, my C is just pi over 2. But it's not, because I have another horizontal transformation going on here. So we have to factor that in. So to find C, we have to divide it by B to get that phase shift of pi over 2, to get that to be pi over 2. And folks, once we write the equation, we'll kind of check this and you'll see why, like, oh, I understand why we have to like divide it by B now, because when you go to solve it where it starts and ends, that's obviously factored in. We know B is 2. So solve this for C times both sides by 2. C is pi. Okay, with me so far. What would D be?
+1.
Positive 1. Good. Shift up 1. So my equation here, amplitude of 2, sine of 2x minus pi plus 1. Now, let's set up our little inequality and just see why we have to factor b into finding c. Because we're going backwards. So when I solve this, I would add over the pi. And then I end up dividing by that b factor, right? So I would divide by 2. So, oh, I see. Now I'm starting at pi over 2. There's your phase shift. All right, so you can't just take whatever this is. If there is a b, again, we're working backwards. We're trying to get to there. If there's a b, you have to factor that in. Kind of make sense? We're going to do one more.
Okay.
Make a little bit more sense, Jackson, or you want me to explain something differently?
I think I got it.
Okay.
Looks like we're gonna do 2 more in total.
Yeah, but the other one we're going to use it. Well, yeah, actually, we are kind of doing enough. 2 more. Okay, this one is a cosine curve. This one has a period of 4 pi. So this one got stretched out. So my b factor should be pretty small. Because a horizontal stretch comes from a small b factor. Remember, those horizontal ones are always backwards from what you think. So again, this is going to affect my b. Amplitude of 3. Okay, no problem. Right phase shift of pi over 4. That's going to affect my c. And a vertical translation down 2 units. That's going to affect my d. Okay, so this one's cosine, but the equation is exactly the same as that sine one. where I have A times cosine of bx minus c plus d. Okay. I'm going to start just reading this problem through again, picking the information left to right. So first I know the period is 4 pi. Well, I know my period is 2 pi divided by b. So if my period is 4 pi, I can do a little algebra here. And again, a lot of you could probably figure out what this is without like setting up this, but this works every time. B is 1/2, which makes sense because we knew that stretch or shrink factor, well, I shouldn't say stretch or shrink, stretch in this case, stretch factor should be a number that's smaller than 1. All right, so B is 1/2. A is what?
3.
3. Love that one. Easy. My phase shift, I'm going to have to factor in B, is pi over 4. My phase shift is pi over 4. C over B will give me pi over 4. If I know B is 1/2, times by 1/2 on both sides now. Careful, don't times by 2. You gotta times by 1/2 to get rid of that. Yeah, pi over 8. D is?
-2.
-2. Good. Okay, let's write the equation. And then let's check the period and see if it matches with the information that was given to us. 3, amplitude, cosine. Now, usually you'll see it written like this, like x over 2. You can do 1/2 x if you want. I actually wrote 1/2 x on my answer key. That's fine. Minus pi over 8 minus 2. Okay, we're thinking this is our final answer. Let's quick check the period. All right, if I add pi over 8 to 2 pi, that'd be 17 pi over 8. And if I times everything by 2, oh, no. Do you see where that went? Oh. Did this give me a starting position of pi over 4? Yes, it did. It'd be 17 pi. That's what this is. Okay, so we're good. Okay, we did 4 examples. Feel like it makes a little bit more sense after doing all of those? Or do you guys want to do another one?
Nope.
Looks like we're gonna do another one.
We're going to do another one, but our grapher's going to help us a little bit. And it's pretty fun.
I just.
Wait.
No.
Yeah, go ahead. Okay. So, Tyson asked me an interesting question yesterday in RTI. He was like, oh, Miss Hendrich, and this is like a pet peeve of mine with students. When I'm not running, I'm also real life. But he did. He asked me. Classic tears. And I said, why don't you Google it? Tyson, what did you find?
I don't know.
Engineering was one of them. Anybody interested in being an engineer? Yeah. I said it's sometimes like modeled like in temperature. This one we're doing today is about depth of a water, like from a dock. So real life data is not that nice, right? Okay. This table shows the depths in feet of the water at the end of a dock every 2 hours from midnight to noon. So t equals 0 corresponds to midnight. 2 hours after midnight, 4 hours after, all the way up till noon. Use a trig function to model the data. And then we'll answer this follow-up question for B. So we're going to put this into our graphers. So the first thing I need you guys to do is make sure your scatter plot is on.
Do you want us in degree or radian mode?
Radian. Every time you're graphing trig functions, you got to be in radian. Good question. Make sure you're in radian mode. I should check mine.
Yeah.
Oh, I was in degree. Phew, good save. Radian mode. All right, so you got to go to stat plot. So you hit second y equal. And mine says off. Yours should be off. If you hit enter, it'll take you to this screen. And you're just going to hit enter again. So it switches to on. Just one. I'll go back again. So you're going to hit second y equals. So you should say plot 1. It should say off. Hit enter. Hit enter again. So it's on. And then go second y equals. So just make sure everybody says 1 is on. If you want to change the color, you can. Okay, so we're going to enter this into our stat edit in here, into our L1, L2 lists. So you're going to hit stat. And then we're going to hit enter because it's edit. And then we're going to type in all this data. This is, remember that one we did before with temperature?
Oh, thank God.
If you have values in here, hit the up arrow until you like highlight on it and just hit clear and it should clear it out. Like that. So if I want to clear this list, I hit the up arrow, hit clear, and then just page back down. It should clear it all out. Yes.
My screen. Wait. This country. Oh, that's the dollar. They go down 2. You just gotta press clear once and then press down.
Okay, let's see if it matters. I'm curious. I've never seen that.
So how do I?
Clear them out?
Well, clear them.
Yep. Go all the way up to here. So you're highlighted on like L1. Hit clear, and then hit down. If you've gotten this far, you can start typing in the data from the table. You can, but you probably have to adjust your window.
It's a straight line.
You gotta adjust your window.
Yeah.
I see all the points, but it's a straight line.
What should our window be at?
Bro.
I put my window at here. I'll write it down. For X, I did. Well, think about it. Our lowest X is 0, right, and our highest is 12. So I did 0 to 13. That's for our time, our hours after midnight. And then for the depth,
0 to 15.
I went 0, and it doesn't go higher than 11.3, so I did 0 to 12 for my Y.
Why doesn't it trace it?
Because it's just a scatter plot, because we don't actually have the equation yet. And that's what we're going to find.
What? They should at least give us a line of
Yours look like
There is a button in your calculator to do it. I'm going to show you.
Getting there.
Okay, everybody good?
Oh, I need to redo my window.
What is the scale? Like the Y scale?
That means like what it's going to count up by. You can just keep it at 1.
What is? Mine's at 2,000.
Wow,
Whoa.
that's crazy.
What were you graphing?
Wait, what is
Ooh,
the
dude,
triangle
yeah.
X?
That is so cool.
Does it look like a sine or cosine curve?
Yeah,
Yeah.
looks like a cosine.
It does look like a cosine. That's what we're going to model.
Does it look like this?
I was just.
Oops, I have
Alright.
something.
Feeling.
If you have something in your Y equal, clear it out. If you don't have your stat plot turned on, it won't plot it for
That's
you.
cool. It's just like yours, and that's a good thing.
Mine has a
Why are my
line
dots
through
so
it.
small?
You like small things,
Yeah, mine has a line.
Well, your screen, did it work? No.
Dude, that's like
that's
small.
like
I'll go check the picture.
I'm gonna go to 15.
Okay. So I want to change it.
Oh, why is there so many gosh darn
Clear list. Done. Oh, did it clear it? Well, I mean, it cleared it, but it didn't. this right there. You can use Precalc.
I have a question.
Yes.
How would
Ash,
you
what's
say
your
it was
question?
Why is my triangle x equals?
I think I actually already have this typed in here. Oh, you have the answer in here. You have the equation. Let's try that. What's wrong?
They should make these things more user friendly.
Maybe it's the operator. Yeah.
No.
That's why my trace steps.
He's not the smartest.
That's okay.
of the batch.
That doesn't matter. It's like my graph
You
is
did 0 to see. I did 0 to 13 and 0 to 12.
Two
Yes.
You did a little different. Okay, you're good. All right.
Shave right.
So we're gonna find this equation now. It looks like both the sine and the cosine curve, right? Now the reason why we're gonna call it a cosine curve is because we have exactly like half of a cosine curve here. If we start at this max and go down to this min, if we find the equation of like that half, like I don't have like a full sine one. I don't have a full, intercept to intercept. We could, I guess, call it a sine one, but we're gonna model this with cosine. Okay. So in your notes, here's what we're gonna do. We're gonna basically do the exact same thing we were just doing with finding the equation. We're gonna use this data.
Amplitude.
Okay. So we're gonna use cosine to model this, but again, technically you could use either. Let's start with our amplitude here. So remember our amplitude, we would take our max minus our min, high point from the low point. I guess this would work for like midline too, and then we just gotta find like half of that distance. So what was that maximum point? You can look at your table there. 11.3, good. What's the lowest point? 0.1. All right, so we get 5.6 for that amplitude. Okay, there's our amplitude. Let's figure out.
I agree.
Okay, let's figure out the period now. So again, we only have like half of a period. So you gotta figure out what's the time at that max, what's the time at that min, and then we'll just double it to figure out our whole period. Okay? So in this case, I'm gonna find like this length right here. So the time of the min, and I can write this out too. So to find B, or actually I'll do this, period.
Like,
I did my time of my min, because that's my x, minus my time of my max. I found that length.
Oh, it's min minus max.
Well, in this case, because I'm finding like this length right here.
it's difference.
Yeah, the difference between them. And then I just doubled it.
Are we gonna have these on the home assignment?
I don't know if there's one like that. There might be, I don't know if there's one like this. There might be one.
As
All right, so the time of the min was at 10. 10 hours after midnight. The time of the max was 4, so that length right there was 6. So our period should be 12. Okay, does that make sense? Now, if your graph gives you like a full period, you wouldn't have to like double it, obviously. But our period for this little chunk that we picked at this distance, I know you probably didn't have to go through the math to find that that was 6. But again, if you're not given nice numbers with data, it's good to kind of know our thinking here. Double it. So we know our period is 12. So now we can figure out what B is. Because I know my period, which is 12, is 2 pi divided by B. So, yep, B is pi over 6. And we're actually going to write it as a decimal since we're doing an application problem. So, I mean, I wouldn't, if you leave pi over 6, that's great. 0.5235 is what pi divided by 6 is. Okay, what can we find next now that we know B? C. C is C over B. So we kind of have to look at like where this curve starts. Where our curve starts. for the cycle that we picked. It's starting at 4. Yep. So we're thinking it's like shifted over 4, but I got to factor in B. So it's starting at 4. And if B is pi over 6 times both sides by pi over 6, 4 times pi over 6 is 4 pi over 2 pi over 3, which, yes, counter that decimal was perfect. 2 point, what'd you say, 0.9? Okay, good, we found C. Now D, my midline is half of my max and my min. Now it's a little different than amplitude. In this case, because we're starting at 0.1, we're not starting at 0, right? When I'm talking starting, I'm saying like my lowest point. So my midline actually ends up being, what is that, 5.7? 5.7.
How can we add that?
Because we're not starting at 0. Oh, you're basically like finding like the average in the middle. But the amplitude is like the distance between. Does that make sense?
Yeah.
We could have found the midline first and then found the amplitude by doing like the max minus the midline. We could have done that. But this one, think of it, you're finding like the average in the middle. And just be careful because it's not right at the y-axis. It's actually at 0.1. Okay. So our equation is this. And we can type it into our y equals and see how close it models our graph in a second here. Well, when you zoom out like that, my handwriting stinks. Okay, so here's our equation. Let's write this down. Y equals 5.6 is the amplitude. Cosine of, I'm going to do decimal. If you want to write pi over 6, that's fine, especially when you go to type this in your calculator. T minus C plus D.
Oh my god.
Okay. Oh, shoot, I feel like we're just going to run out of time. We'll finish this tomorrow. So go ahead and type that in your y equals, and it should go through most of your curve here. So 5.6 cosine, I'm going to do pi over 6 x minus 2 pi over 3
I guess we have to drop Precalc.
plus 5.7. Look, that's pretty good.
I missed.
I'll show you tomorrow. There's like a regression tool in your calculator that finds it for you. We'll do that tomorrow. Okay.
Really, that's what I forgot.
It's the homework.
You don't have to